Hello, everybody, and good morning. Thank you guys for getting up and joining me here today. I know it was a late night for me. My name is Eitan, and I lead the developer engineering team on Project Tango. And today, I want to walk you through some of the capabilities of the device, but more specifically, I want to focus on how you might build an augmented reality experience with Project Tango. So I know we've been relatively popular here at I/O. How many of you have seen a Project Tango demo while you've been here? Yeah? Did you like it? Yeah? All right. Great. So that's a lot of you, but not all of you. Just a quick shout out. We will have the sandbox going throughout the day today. So after this talk, if you want to go by and check it out, you should definitely get your hands on Tango for yourselves, do a demo. All right, so for those of you who haven't heard of the platform, I'm going to do a brief overview. I'll keep it relatively brief. I really do want to spend most of my time talking about how we actually build applications for the platform, as well as the APIs that we provide for augmented reality content. Clicker. Awesome. Right, so our brief overview. Project Tango fundamentally is about extending the capabilities of our mobile devices beyond the screen. If you look at your phone today, you interact with it mostly with your head down, touching different buttons, maybe swiping through photos. Really, the only way that your phone interacts with the world is through pictures and videos. And Tango seeks to enable your phone to do much more, to gain an understanding of the physical space of your environment, to be able to track the position of your device as you move through space, and also to be able to sense the geometry of your environment as well. When you have these capabilities, it allows us to turn your device into a magic window into the world. We can play games like Jenga from Shell Games, where you place a virtual Jenga tower on a table in front of you, and you don't have to clean up. We can do things like measure your sofa. You can measure the height from the ceiling to the floor without playing the game where you see if your tape measure falls over. And we can also, towards the future, navigate from point A to B in space. So imagine going into a mall and wanting to know even where your friend is in the mall and being directed in an augmented reality view to them. So that's kind of what we're working on. And to enable these kinds of applications, we provide a couple of core technologies to developers. And you've probably heard of these if you've been to some of our other talks. But they are motion tracking, depth perception, and area learning. And I'll go through each of them briefly over the next couple slides. So motion tracking is really the core technology upon which Tango is built. And motion tracking allows Tango devices to understand their relative position and orientation to where they started. So if I just use my device as a prop, as I move with my Tango device in the world, it knows that I've walked, say, a meter forward and turned 90 degrees to the left. And this is the motion tracking capability of the device. It's using visual features in the environment, combining that with inertial sensors to estimate position. The second piece of technology that we expose through our APIs is depth perception. And depth perception allows our Tango devices to see in 3D. So on our tablet here, we've got a special depth camera, and it projects infrared light out into the world, and it has a camera that can see that infrared light. And by seeing the pattern, it can judge, okay, my device is a meter to this surface. And so I can start combining motion tracking with depth perception to do things like real-time meshing of environments. And it's very powerful. Now you have an understanding of where a table is, where a chair is, and where objects are in the world, and your applications can start to take advantage of it. And the third capability of Tango devices is area learning. And Wim gave a talk, I believe 2 days ago, on area learning, but it's the memory of the device. It's the ability of Tango devices to remember where they've been before and to recognize spaces. So if you think about coming into this room and maybe you see, the exit sign at the back, if the device saw the same thing, it remembers roughly how the exit sign looks. It remembers how the scaffolding here looks around it. And so when you walk back into that space, a different time, or if you have multiple devices, they recognize where they are relative to that landmark in the world. And with that, you can enable multiplayer experiences because you have a shared reference frame for Tango devices. And you can also enable, towards the future, things like this indoor navigation use case, going from point A to B, because the device knows what space it's in. OK, so at this point, we have actually gone through everything that I normally get to talk about. I have never gotten to go deeper on Tango technology than this. And here we're through it in like 7-ish minutes. So I feel pretty good. And I'm really excited about this next part. We're going to go deep on how you build for AR, the considerations that you take into account, the different pieces of Tango technology that enable you on a journey to better and better AR. And also, we're going to talk about some of the limitations of augmented reality as well, and how you can be creative in building applications that work around it. And so, for something of this magnitude, I was thinking to myself, OK, what are we going to build? What am I going to show here? And I was browsing the internet and looking around and thought, what really represents the internet? What really brings it to life in front of us? What could we do that just represents the magnitude and scale of the occasion? And so we are going to build a cat game in augmented reality in front of you. The most majestic of creatures. And specifically, we're going to take virtual cats and we're going to put them into our physical world. All right. Also, in preparing for this talk, I was procrastinating a little bit. This Wikipedia page is way better than you think, if you want to check it out. I know, it's surprising, right? All right, so back to our cats. Let's say our idea is to bring as many cats as possible from virtual space into our physical environments. We've got 3D models of all of these cats. And we want to bring them to life in 3D. So where do you even start? This picture is kind of the ideal of what we'd be going for, but it's really hard to achieve. So we're going to take some steps along the way, and we're not going to get all the way there, but starting is hard. So first, I'm going to take a step back a little bit. How many of you have experience with linear algebra, 3D geometry, coordinate frame transforms? All right, that, for an audience, that's pretty good. All right, but I'm going to do a little bit of a refresher, and also just as comfort for everyone else, I'm not going to go too deep into that. We're going to keep it fairly high level. But mostly, I'm going to talk about the coordinate frames that Tango defines as they relate to each other, and as they relate to the device as you move it through space. All right, we're back to our cats. So the goal, again, is to take a virtual cat and to put it in our physical world. So here we've got a living room, we've got our virtual cat, and we want to place it on the Ottoman. And the cat should stay fixed in the environment as we move around it. And ideally, it would even interact with the environment a little bit. So maybe the cat jumps down from the Ottoman to the floor, or it jumps up on the table. Just a little bit of playfulness. So easy enough. All right, we've got a couple of things going on here that we need to cover first. We've got the camera feed. So the camera is the 2D projection of the 3D world onto an image plane, is seen through the lens, and it comes in at 30 frames a second on Tango devices. So as I move my camera around the world, I might get a different view of the sofa, of the fireplace, of the TV and the table, and that 3D view is compressed onto this 2D image plane, and it's in color. And in the real world, when you're walking around, you don't have to worry about much beyond this, right? Physics takes care of it. Physics is awesome. And the light comes in, and you just get different perspectives based on how you walk around. But now we're talking about compositing a virtual character into this physical scene. And it gets a little bit more complicated. The cat doesn't actually exist in the real world. So to understand how we render this cat as if it's in the real world, let's forget about the real world entirely for just a moment and explore this problem. So say instead of in the real world, we've got a virtual cat, and we want to render it on the screen of our device. We want to place it approximately 2 meters in front of the device and hold it fixed and just move around it. For those who are familiar with building 3D games, this is very, very similar to how a camera system in a standard rendering engine works. We're going to place our object in a coordinate frame called the world frame of the game, and then we're going to render it relative to the frame of our camera as it moves around it. And at the start, we'll view the cat from the left, and at the end of our motion around the cat, we'd like to see it from the right. And it always stays fixed. So with Tango, this is exactly what we'll do. It's just that instead of programmatically setting the transform of the camera as it moves in the world, we're going to get it from the Tango device itself. Tango has a couple of coordinate frames I'll talk about that are relevant for this. So the world frame for Tango is represented as start of service, and it's wherever you started with the device. And the device frame is wherever you currently are with the device. So if I start here, that defines start of service. And if I ask for the transform between start of service and device, when device is here, it'll give me sort of 2 meters. OK. So now to show this a little bit, I'm going to give a demo of what this looks like in action. OK. So here, I've got a completely virtual world. And I've got this cat. We'll call him Mittens, I guess. And as I move around Mittens, he stays fixed in the virtual world. But he's not tied to my physical space in any way. I can make him walk, but it's just on a plane that exists in space. And he can also, I guess, paw on the camera when I get close to him. All right. Yeah. It gets better, I promise. All right, we'll go back. So to make this a little more concrete, I want to just show the calls that you need to make in our APIs to be able to do this. So Tango provides a function called getPoseAtTime, and you can pass it the base coordinate frame that you would like, as well as the target coordinate frame that you would like. And it will return you the transform at that point in time. So here you can see I'm defining a frame pair where I want to ask where is the device relative to the start of service. So my base frame is start of service, and my target frame is device. And I say, get me the transform at time t, where maybe time is now. And that timestamp actually turns out to be really important when you're trying to do things like composites onto an image, because the camera takes an image at a very particular point in time. And so that's something that we'll be coming back to make sure that the cat is well registered with the environment when we go to composite it. But overall, this is pretty simple, right? You can just at any time ask for where the device is in the world. And boom, you've got a handheld AR cat viewer. All right, so it's not exactly what we're looking for, though. The goal, again, is to place the virtual cat on the Ottoman in the physical world. And the first thing you might think of doing is just taking the RGB image, and we're just going to slap the cat onto the RGB image, and it's going to be fine. We'll just use that as the background. But it's not going to look quite right. This slide demonstrates it, but I'll go to a demo again just to make it a little more clear. All right, so now we've got Mittens, but he's not looking super awesome. He's just floating in space in front of me. And here, I really would rather he be on the ground. So that's what we're going to work to do. But if you were to build an application like, say, a sun, with planets orbiting around it, this could be an appropriate visualization. But for Mittens, it's really it's all wrong. So we'll go back to our slides, and we'll see that it is really, really wrong. All right. I hadn't looked at that image in a while, so I like it. All right, so what can we do to fix this? Well, there are a couple of things that we can try. Before we go down this road, though, it's worth mentioning again that perfect augmented reality is largely an unsolved problem. So we're going to talk about some things to make the cat look better, but it's not going to be perfect. I've learned to manage expectations, so you'll see me do this throughout the talk. But we're going to get better, and we'll talk about the limitations in detail at the end. Next slide. OK, so with that public service announcement out of the way, how far down the road can we go with Tango? Step one is that we can tie the cat into the environment using Tango's depth sensing APIs. So I mentioned before that the device doesn't just understand its position in space, it also understands the geometry of the environment. So maybe we can use the Tango device to actually decide where to place the cat, to recognize surfaces in the environment, and then we can tie it to the floor at the correct size and scale. And Tango provides exactly these capabilities through our support libraries to developers. You can essentially ask for a given pixel in an image, give me the point and normal in the world frame of that pixel. And then we can place the cat there. And to show this, you can see that this is the code needed to compute that point and normal in space. So the first thing that we do is we need to get the relative pose of the depth to the RGB image. And this is a little bit subtle. So as you're walking around, we're taking RGB images all the time, but we're also firing the depth camera. But they're not actually taken at the exact same time. There's a little bit of an offset there. So if I naively took the point cloud at the timestamp of the RGB camera and just selected a point, it would be off a little bit. It wouldn't look correct. And what I need to do is actually transform the depth information into the frame of the RGB camera. So here what you can see is we're calling a support function that says calculate the relative pose between the color camera and the depth camera at the last time I had a color image and the last time I had a point cloud. And then from there, we call fit plane model near click, and we pass in the point cloud, we pass in the color image, and we pass in the relative transform between the two, which helps us do that alignment. And then we get back a point and a plane model for that pixel in the image. And after this call, we've got a point and a normal that we can use to place the cat on the correct surface in the environment, and we can put it in the real world. So I'm going to show a demo of that now. Can we? Oh, awesome. So here you'll see that Mittens is actually looking pretty good. He can move around the world, and every time I tap, I'm getting that detection. And you can see that I can make Mittens sort of interact with the surfaces and the geometry of the environment. OK, we'll still get cooler. I like the enthusiasm, though. It's sort of building over time. So I can have Mittens jump on this as well. And he can jump down. And if we like, we can also change Mittens to Rufus. Yeah. All right, so let's go back to the slides. Okay, so we're getting better. But you'll notice that I didn't have the cat go behind anything. And the reason I didn't do that is because we don't have support in that demo for occlusion. What that means is if I had placed Mittens behind the podium and looked at it from kind of the incorrect angle, I would have seen through the podium, and Mittens wouldn't have rendered realistically. And so what can we do along the way to maybe do more about understanding our scene and our geometry and our environment to make Mittens look even better and even more realistic? Well, Tango can create rough 3D reconstructions of the world environment. And it provides developers with these meshes in real time, which is really, it's kind of crazy when you think about it. And perhaps we can use these meshes to help a little bit with our occlusion problem. So now, instead of using a single point to determine how to render the cat and to have Mittens jump from the table to the chair to the floor, we can use like the full 3D structure of the environment and aggregate many points over time. So under the hood, when Tango is meshing, it's actually taking many, many different viewpoints, doing sort of that same transform I talked about to get the point cloud into the world frame, and binning them over time and creating a representation of this surface that gets better, actually, the more that you look at a surface, because you get more points of data and a better accurate of the surface. And this process is pretty complex, but it is, again, abstracted for us by the SDK. And we've got a meshing library that you can use in C++, or we've hooked it up directly to Unity for Unity developers that gives you the mesh inside the game engine in real time. And that makes it really easy to use it in our depth buffer as we render. So to see this, we're going to check out another demo. All right, so we'll put Mittens over here for now. So you can see that as I move around the podium, I'm starting to build up a rough mesh of it. That's probably good enough for now. And we'll put Mittens sort of in the background. And as I move, you can see he becomes occluded. And we think that this is a really powerful thing for building AR applications. We can sort of bring him out. Yeah. So one thing that you'll notice is that the mesh isn't perfect, and so we'll play some tricks, like we actually alpha blend on the edge of Mittens as he goes behind. And here we've even shown you his silhouette when he's behind the podium to give you a sense that he's still there. I'm going to show another version right now that does a similar thing, but it's not going to show the silhouettes. So Mittens will be fully occluded, and you'll get to see how that looks as well. Should have saved my mesh, but OK. So probably good enough. All right, so now we'll put Mittens behind again. And you can see as I go, he kind of pops out over time. And there's alpha blending on the edges that we're using to sort of make him fade in and out. So it's not perfect, but it does give the illusion of a more real experience. All right, let's go back to the slides. So at this point, we've actually created a pretty compelling augmented reality application, I would say. We've taken Mittens, we've placed him in the world, he can walk on surfaces, he can jump on chairs, and now he can actually be occluded by objects in the scene. So you've got a lot of the components of making a compelling augmented reality experience right there in front of you. But it can be a lot better. And one thing I'll say, have you guys noticed anything weird about this picture up here? Does something look fake to you, maybe? Yeah? People are nodding. Audience participation. No, the Lamborghini's fake. It's fake. So the front one is actually not a real car. And the reason that this looks so good is that we're doing a lot in terms of lighting and reflection. We've placed it exactly where we want. We've done very detailed compositing of it. And this is kind of like the Holy Grail, right? This is the Holy Grail of AR. And this slide is really just to say that this is a journey, and we're moving along this path, moving towards things that we hope someday can look like this. But this is not, I guess, the expectation to have today for where we are. And as an application developer, it's important to remember that. So if you're building something, you want to ask yourself, is it appropriate for the technology that I have at hand? And everything from the art assets that you use to the gameplay that you design can help to set expectations for your users. And you can still make really compelling experiences that use maybe a subset of the technology as well. So you could put a solar system in space. You could have your cat walk on planes but not be occluded. Or you could have objects in games that take advantage of the scene geometry. But all of them are compelling in their own right. And with a little bit of creativity, you can actually make experiences that feel really good to people, even if you're not leveraging the full capabilities of AR, and even if you don't get to the Holy Grail of Lamborghini rendering. And to illustrate this, I guess I'll provide two examples of augmented reality applications that I really like that don't even use depth. All right, so the first one I've been alluding to for a while. This was done by some of our friends at San Francisco State University, and it allows you to explore the solar system by placing planets in a line in your room. And I'll show a demo of that now. All right, so here I'm going to tap to place the sun. And now I'm going to walk. And I guess it recommends I go further than this, but this is about as far as I get. And I'll tap to place Neptune. So now as I walk back towards the sun, I can see the scale of the planets relative to each other. And it's actually correct. And I can zoom in to each one of the planets. And if I want, I can start to see how orbits work. And as an educational tool, this is spectacular. And from an augmented reality perspective, it's actually remarkably simple. I mean, this is the floating cat that we all laughed at before. But for the appropriate application, it's actually quite compelling. All right, we'll go back to the slides for a second. The second application I want to talk about is a game from our friends at Trixie Studios, and it's called Fantageist. And how many of you actually went to our after hours event and got to play Fantageist? Oh, that is way too few of you. All right, so Fantageist is a game. And the premise is that aliens have invaded your world, and you need to zap them before they take over the world, and it's not good for us at the end. But anyway, there are a bunch of design considerations that went into this game that I really like. So the characters are actually semi-transparent. They feel like they're coming out of the wall. And they're very clever about using the position of the device and making assumptions about free space to interact with the world even though they don't know where surfaces are. And I'll show a brief demo of this, actually. So I'm going to go to bonus contents, and we'll do a giant worm thing. All right, so you can tell they're already setting the mood with the music that they have for this. And what happens is, as I start, the device records my position in space. Can we turn down the lights? Awesome. So we'll get a brief text message that says something like, "The aliens will get you," or "clear the area." And so as I move, you'll see kind of something strange happens. So here we've ripped a hole in the actual floor, and we can see into, whoa. All right, we're safe. So if we switch back to the slides real quick. Yeah. I think it's pretty cool. All right, so everything that you saw there used only motion tracking. There was no depth, there was no occlusion, and it's kind of shocking. I'm actually impressed with how well they pulled it off. But they're playing tricks, they're making some assumptions and building gameplay that just works for the environment. And so really this is to say that, there are ways in gameplay to make things feel real and immersive, even with our most basic APIs. And as you start to move down the road, it gets just better. And with all that said, I've said a lot of, managing expectations type stuff, but we're continuing to improve. We're always working on new things. And in fact, we're rolling out some drift correction code into our SDKs over the next couple months. So Wim talked about this before, but another problem that you have with augmented reality is that when I place the cat in the world, actually, let's switch back to the demo just real quick. I think it's easy to show. So you can see that the cat is on a surface. It's relatively robust to when I move the device around because our tracking is relatively good. But if I'm really mean, okay, the cat is gone, right? It drifted off into space. So we can go back to the slides. So we've actually built software that allows us to correct for that. And so when the cat goes drifting off into space, we recover very, very quickly. It takes about a second, but you stop, look at the world, and the cat shows up back in the correct place. And this is really just one of the improvements that we're working to roll out and that we're working to bring to you, our developer community. We're working on things like modeling the lighting in the room to give you realistic shadows, things like improving our meshing and doing texturing as well to give realistic textured meshes inside of Unity that maybe you could use in other games and even import them into different game worlds. We're just kind of taking steps along this journey to getting to that Lamborghini, to getting to really, really good and immersive and solid augmented reality. But we don't have to wait. We can already do a lot right now and build compelling experiences today. I also want to talk a little bit about the trade-offs that you make as you start to use more and more of this technology. So heat is your enemy on a mobile device. If any of you have used a mobile phone before, you know it gets hot. It's hot in your pocket. You're using Google Maps, and it's just like burning up. And it is a very real trade-off. So we've worked hard to optimize our algorithms, to optimize our computer vision software, and to make it run as quickly and efficiently as possible. But the more capabilities you use, the more heat and CPU and compute you use as well. So if you can make an experience work with motion tracking, then you have a lot more that you can throw at your game. But if you go all the way to full meshing, maybe you should be using some low poly models. And it's just important to be aware of the trade-offs that you make when you think about the applications that you could build. If I could sum up my talk with like one cheesy statement, I would do it with creativity is king. When you're developing for a new platform, there are limitations, and we're super fortunate to have partnered with people who can be creative and who have worked around the different capabilities and technologies of the device as well as their limitations. And we're really looking forward to seeing what kind of creative applications can be enabled by what is super powerful technology over the coming months. There's a bunch that you should check out at our sandbox to get a picture of what developers are up to. If you haven't done that, I really encourage it. And there are a couple of things that we've done that are really exciting at the platform level too, looking forward. So first, we believe that Project Tango technology should become ubiquitous. All devices should have the ability to understand where they are in space and to understand the geometry of their environments. And one thing that we've done is we've worked closely with our friends at the Android team to start moving some of Tango's APIs into core Android. And so in Android N, you can actually ask for the 6th degree of freedom pose of the device through Android APIs. And Android N also supports depth sensors. And over time, we hope to expose more of Tango's capabilities in this way. And we're at the beginning of a very, very exciting journey on the consumer front. So we have announced a partnership with Lenovo where we will be shipping Project Tango smartphones later this summer. And this is huge. This is a big deal. This has been a 3-year journey for us to take this technology from the prototype stage all the way to something that you can actually hold in your hands. And a lot of the applications we're showing here start to show the power of these devices for consumers. So now is really the time to get on board. Like the train is sort of like leaving the proverbial station. And I'm really excited to see what we can build together. It's a great time to get your foot in the door. If you haven't been thinking about augmented reality applications, I encourage you to do so. And it's also a unique opportunity to partner with Google. So we're always looking for interesting ideas. We like to feature our partners at things like talks. And on occasion, we even put out like RFPs for unique augmented reality content. And this all happens because it's a new and budding ecosystem. It's just an exciting time to sort of take the first step in this journey together. All right. And with that, I'm ending my talk. Hopefully, this gave you an idea of the kind of applications that are possible with Project Tango, as well as some of the considerations that you need to be aware of when you're building augmented reality content. I think it's a really exciting time. I'm really happy to be here, feel fortunate to be on the team. Thank you guys so much for your time this morning. And yeah, hope you enjoy the rest of I/O.